Hi everyone and welcome back to the channel. Imagine you are given n binary strings, each of length n, and your task is to create another binary string that doesn't exist in the list. Sounds easy? Here is the twist. There are 2 to the power n possible strings, but you only see n of them. So how do we guarantee a different one in O of n time? The trick comes from a 150 years old mathematical idea. So let's understand the problem together. Today, we will solve the lead code problem, find unique binary string. We are given an array of strings containing any unique binary string, each of length n, and we need to return a binary string of length n that doesn't appear in num in the array. If there are multiple answers, we may return any of them. So, for example, if we have an array like this one, it has a binary string. Each string has the same length as the array. So each string here of size 2. Our goal is to return any binary string of length n, here of length 2, that doesn't appear in the list. For example, a valid answers here in this example could be 1, 1 and 0, 0. Your first thought to solve the problem might be to generate all the 2 to the power n binary string, then check which one is missing. But that's terrible. Why? Because 2 to the power n grows exponentially. Even for n equals 16, which is our limit here, we will have near a 1 million of possibilities. Or maybe you could have another idea, like you may think that since there are only n string in the array, as described here, we need to check only n plus 1, an extra check over n, different binary string, since at least one of them wouldn't appear in the array, and thus that could be a valid answer. But although this is gonna work better than the first solution, but still would need O of n to the power 2 time. So we need something much smarter. That is where a famous idea called Cantor's diagonal arguments come in, and it guarantees we can create a different string instantly. Here is the trick. Look at the diagonal elements of the matrix formed by strings. For example, if we take this array as an example and we arrange it in a matrix, it's gonna be looks like 1 1 1 0 1 1 and 0 0 1. So if we look at the diagonal element of the matrix formed by this string, so the diagonal element would be the element at index 0 0 and 1 1 and 2 and 2 in this example. Now, if we flip every diagonal bit, so if we flip the 1 to 0, and this one to 0, and this one to 0, the diagonal bits will form a new string that differ from string 0 at the bit 0 and differ from string 1 at bit 1 and will differ from string 2 at bit 2, which means It cannot equal any string in the list. We just constructed a guaranteed unique list. So in this case, the unique string, generated string, will be formed by the diagonal bits will be 0, 0, 0. Now, let's translate this idea into code. First, we get the size of the list. Let's say n equal nums dot size. Then we create a string of length n. Let's name it result string, result of size n, and initialized with the character 0. Why I defined it like that? Because that's better than or to avoid repeated resizing of the string. After that, we loop through each index and we flip the diagonal bits. If the diagonal bit is 0, then we'll add 1 to our generated new string, else the character 0. And finally, we return the result. Let's run it to make sure it's an error-free. Yes, and all the test cases pass. Let's submit it. And as you can see, it beats 100% of the solutions. So let's analyze the performance. We only loop once through the array, so the type complexity is of n, where n is the length of the array, and the space complexity is of n2 because we are using a string of size n to hold the result, and that's optimal. And that's all for today's problem. If this trick surprised you, like the video and subscribe to the channel, and I'll show you the next one. Happy coding. See you. Bye.